Hello and welcome. In this video we want to talk about average rate of change and instantaneous rate of change. The average rate of change of the function f of x over the interval x1 to x2 can be defined by this formula. The average rate of change of the function f of x over the interval x1 to x2 is f of x sub 2 minus f of x1 over x2 minus x1. The numerator is change of y of the function and the denominator is change of x. And it reminds you probably rise over run. But what is instantaneous rate of change of a function? Instantaneous rate of change of a function is derivative of the function. So basically, when you are finding derivative of the function, one of the interpretations for derivative is instantaneous rate of change. So whenever you want to find instantaneous rate of change of a function at a point, simply find derivative of the function at that point. Let me tell you the difference between average rate of change over an interval and instantaneous rate of change at a point by a simple example. Suppose by a car you move from point A to point B, and let's say I am asking you, what was your average velocity when you moved from point A to point B by your car? And maybe you are saying me, my average velocity was 60 km per hour. This 60 km per hour is your average velocity. Now consider this question. I am asking you, okay, at this point here, what was your velocity? For example, you are saying me 75 km per hour. What was your velocity at this point? 55 km per hour. What was your velocity here? 52 km per hour. As you can see, at different points, you have different velocities. These velocities are instantaneous velocity. But when I'm asking you your average velocity, I am talking about an interval. But when I'm asking you velocity or instantaneous velocity, I am asking you the velocity at a particular point, at a single point. So average rate of change is over an interval, but instantaneous rate of change is at a single point. And for finding the instantaneous rate of change, you have to find derivative of the function. Now, by doing some examples, we can understand these two concepts better. Suppose f of x is given by x to the 2 plus 5x plus 100 shows the cost of making x units of a product. So, for example, if you want to make 10 units of that product, you can plug in 10 in this equation to find the cost of making 10 units of that product. The question is, find the average rate of change of cost with respect to x when production level is changed from x equals 10 to x equals 15. So we want to find averagely how much change happens in the cost when we change the production level from 10 to 15. Of course, when you increase the production level, the total cost increases. But we want to find averagely how much increase happens per product when we increase the level of product from 10 to 15. Based on the definition of average rate of change, we have to find f of x2 minus f of x1 over x2 minus x1. x1 and x2 are the given numbers. Always when we want to find average rate of change, we need to have 2 points, a starting point and end point. x1 in this question is 10, x2 is 15. So for finding the average rate of change, when x changes from 10 to 15, we have to find f of 15 minus f of 10 over 15 minus 10. 15 minus 10 is 5. But we have to find f of 15 and f of 10. For f of 15, we have to plug in 15 in this equation. F of 15 would be 15 to the 2 plus 5 times 15 plus 100. 15 to the 2 is 225. 5 times 15 is 75. If you add these two, it's 300 plus 100. Totally is 400. So f of 15 is 400. Now we have to find f of 10. For finding f of 10, we have to plug in 10 in this function. F of 10 is 10 to the power of 2 plus 5 times 10 plus 100. 10 to the power of 2 is 100, 5 times 10 is 50, 100 plus 50 plus 100 is 250. So 400 minus 250. 400 minus 250 is 150, 150 divided by 5 equals to 150 over 5 is 30. So the average rate of change of cost with respect to x. If you wonder why it's saying with respect to x, because look at the numerator. Numerator shows the change in cost. The denominator shows the change in x values. That's the reason we say change in cost with respect, or we can think it as over change in x. Now, in the next part, we want to find the average rate of change when x changes from 10 to 11. Then the average rate of change is f of 11 minus f of 10 over 11 minus 10. Denominator is 1. And we know that f of 10 is 250 from part A. Now we have to find f of 11. For finding f of 11, we have to plug in 11 in the function f. F of 11 equals 11 to the power of 2, 5 times 11 plus 100. This is 55. 11 to the 2 is 121. 121 plus 55 is 176. 176 plus 100 is 276. So it is equal to 276. 276 minus 250 over 1 would be equal to 26. So when we increase the production level from 10 to 11, and actually this means that we increase the production only 1 unit, and by doing this, averagely the cost of production increases 26 maybe dollar per unit. This shows the increase that happens averagely. And the students that are familiar with business topics, they know that when we increase the production 1 unit as it happens in this part. When we increase the production unit 1 unit, when we increase it 1 unit, this value shows the marginal cost. This is the term that we use in business courses for this value. So 26 is the marginal cost. So marginal cost is the change in the cost that happens when we increase the unit production only 1 unit. Now we are asked to find instantaneous rate of change of the cost when x equals 10. Whenever you hear instantaneous rate of change, whenever you hear this, whenever you see this, you have to think it as derivative, because derivative has different interpretations. Sometimes we say derivative shows the slope of the curve. Sometimes we say derivative is the slope of tangent line. And derivative has this important interpretation: rate of change or instantaneous rate of change of the function. So when we want to find instantaneous rate of change, we have to find derivative of the function. If you are familiar with derivative rules, simply you can find the derivative of x to the 2 plus 5x plus 100. And if you are familiar with derivative rules, probably you know that derivative of x to the 2 is 2x, derivative of 5x is 5, and derivative of 100 is 0 because it is a constant. And because here we want to find derivative or instantaneous rate of change when x equals 10, simply we can plug in 10 here. 2 times 10 is 20, 20 plus 5 is 25. So the answer is 25. But here in this video, we want to answer this question not with derivative rules. We want to find instantaneous rate of change without derivative rules. We want to find derivative without derivative rules. We want to find it with the definition of derivative. But if you remember, for derivative, we have two formula that we use for finding derivative from definition. Let me show you both of the formulas here first. One formula for finding derivative of a function, let's say we have a function like in general f of x. If we want to find f prime, derivative of the function, at a number like a, in this question a is 10. If we want to find f prime of a, if you remember, we have this formula, limit of f of x minus f of a over x minus a as x approaches a. But we have another formula for finding f prime of a. Limit of f of a plus h minus f of a all over h as h approaches 0. We can use the first formula or the second formula, and they are equivalent, so it doesn't matter which formula you use. For this particular question, I am going to use the first formula, this formula here, for finding the derivative of the given function at 10. But you can use, of course, the other formula. And if you want to get more familiar with these formulas, you can watch my video about definition of derivative. So, for finding f prime of 10, f prime of 10, I am going to use the first formula. Based on the first formula, we have limit of f of x minus f of 10 over x minus 10 as x approaches 10. What was the given function? What was f of x? If you remember, it was x to the 2 plus 5x plus 100. This was the function. And here we calculated f of 10 and it was 250. So f of x is x to the 2 plus 5x plus 100, and f of 10 is 250. So we have x to the 2 plus 5x plus 100 minus f of 10 minus 250 all over x minus 10. If we simplify this numerator, we have limit of x to the 2 plus 5x minus 150 over x minus 10 as x approaches 10. For finding this limit, if you try to find this limit by direct substitution, if you plug in 10 in numerator and in denominator, you are going to see that numerator is 0, denominator is 0, so direct substitution doesn't work for finding this limit. To find this limit, you have to factor out the numerator. Numerator is a quadratic expression, and if you remember factoring quadratics, we can factor this quadratic like this: x plus 15 times x minus 10 over x minus 10 as x approaches 10. X minus 10 from numerator and x minus 10 from denominator cancels. How I factor this? Let me explain this in a moment. We are looking for two numbers that their product is negative 150. The sum of those numbers is 5, and I guess that those numbers should be 15 and negative 10. If you want to get more familiar with finding these type of limits, watch my videos about finding limits using factoring methods. Now that x minus 10 from numerator and x minus 10 from denominator is cancelled, if we plug in 10 here, the limit would be 10 plus 15, which is 25. So the rate of change, or instantaneous rate of change of cost when x is 10 equals 25. Before I show you the next question, look at this number that we got here as the instantaneous rate of change, and look at the value of average rate of change when x changes from 10 to 11. The average rate of change when x goes from 10 to 11 is 26. The instantaneous rate of change is 25. As you can see, these numbers are close to each other. And this is not something random. Basically, when in average rate of change, these two numbers are close to each other, 11 is relatively close to 10. When these numbers are close to each other, the value that we get from average rate of change is close to instantaneous rate of change. So if we wanted to estimate, attention, if we wanted to estimate instantaneous rate of change of the cost when x is 10, we could say it's 26, and it was not a bad estimate because the real answer is 25. Now let's move to the next question. Suppose displacement of a particle moving in a straight line is given by s, or s of t, equals to t to the 2 minus 8t plus 20. Find average velocity over each given time interval, 5 to 10 and 5 to 6. We want to find average velocity. Let me remind you a physics formula. For finding velocity, if you remember, change in position, or you can say displacement over time or over change of time. As you can see, velocity is like average rate of change, and actually velocity shows average rate of change of position. So whenever you hear average velocity, you can find the change in position or displacement over change of time. Now that we know this, let's do this question. So average velocity would be s of 10 minus s of 5 over 10 minus 5. Do you remember the general formula for average rate of change? F of x2 minus f of x1 over x2 minus x1. We use same formula for finding average velocity when we have the displacement equation. So for finding average velocity, you have to find the displacement at 10, the displacement at 5, subtract them to find the change in displacement over change in time. S of 10 minus S of 5 over 10 minus 5. So let's find S of 10 and S of 5. If we plug in 10 in this formula, S of 10 would be 10 to the power of 2 minus 8 times 10 plus 20. 10 to the power of 2 is 100 minus 8 times 10 is 80. 100 minus 80 would be 20. 20 plus 20 would be 40. So this is 40 minus S of 5. Now we have to plug in 5 here, 5 here, and 5 here. 5 to the 2 is 25. 8 times 5 is 40. 25 minus 40 is negative 15. Negative 15 plus 20 is 5. So 40 minus 5 over 10 minus 5 is 5. 40 minus 5 is 35. 35 over 5 is 7. And if we suppose this displacement is in meter and the time is in second, we can say the average velocity is 7 meter per second. But here our concern is not about units, so I'm going to leave it like only 7. In the next part of the question, we want to find average velocity over the time interval 5 to 6. This is a smaller interval. So average velocity from 5 to 6 is s of 6 minus s of 5 over 6 minus 5. For finding s of 6, you have to plug in 6 in that equation. S of 6 would be 6 to the 2 minus 8 times 6 plus 20. 6 to the power of 2 is 36. 8 times 6 is 48 plus 20. 36 minus 48 is negative 12. Negative 12 plus 20 is 8. So S of 6 is 8. S of 5, we got 5 for that, so minus 5 over 6 minus 5, which is 1. 8 minus 5 is 3. Maybe 3 meter per second, 3 kilometer per hour, or different units that we use in physics. So average velocity over the time interval 5 to 6 is 3. In the next part of the question, we are asked to find instantaneous velocity when t equals 5. And attention, sometimes they don't even use this instantaneous word, They directly say you find velocity when t equals 5. When you have only a single number and you want to find velocity at that time, this velocity is basically instantaneous velocity, which means that what is velocity exactly at that moment. So For finding instantaneous velocity, because we know that this is derivative. Remember, instantaneous velocity or instantaneous rate of change is derivative of the given function, derivative of the displacement. So, what was the equation that we have for displacement? The equation that we had was s equals t to the 2 minus 8t plus 20. So we have to find derivative of this function at t equals 5. So the quantity that we are looking for is s prime, derivative of s, at 5. Now again, you can choose between the two formulas that we have for derivative. If you remember, for finding derivative of a function like f, we can use this formula or this formula. It is completely up to you. Again, I prefer to use this equation for finding derivative. And actually, between these two equations, when we have quadratic expressions, quadratic expression, you know that is something like x to the 2, x with degree 2. The first formula, this formula works better if you want to find derivative with definition. That's the reason I prefer to use this formula. So for finding s prime of 5, I am going to use the first formula. Based on that formula, this would be limit of, not x, the variable here is t approaches 5, of s of t minus s of 5 over t minus 5. We have a limit, t approaches 5. S of t is this. So t to the power of 2 minus 8t plus 20 minus s of 5. You don't need to calculate s of 5 again. We did this here and s of 5 was 5. So s of 5 is 5 minus 5 all over t minus 5. 20 minus 5 in numerator is 15, so we have limit of t to the 2 minus 8 plus 15 over t minus 5. Simply, if you factor numerator, it is t minus 5 times t minus 3 all over t minus 5 when t approaches 5. T minus 5 and t minus 5 cancel each other and only t minus 3 remains. And t approaches 5. If you plug in 5 here, the answer is 2. So the instantaneous velocity when t is 5 equals 2. So the velocity at t equals 5 is 2. And again, it's not bad to compare this value, this instantaneous velocity at t equals 5, with the number that we got from average velocity. Average velocity was 3. And instantaneous velocity is 2. Attention, if here instead of 6, for example, you go and calculate the average velocity over the interval, for example 5 to 5.1, a smaller interval, you are going to see that the average velocity over this interval is a number close to the instantaneous velocity. Now look at this example. This example checks your understanding from instantaneous rate of change or derivative, the interpretation of derivative. Suppose h of t shows daily cost for hitting a building. when the outside temperature is T degrees centigrade. Before we start doing this question, let's think to function h of t. So we have a function h of t, which this function shows the cost for hitting a building when outside temperature is T. So for example, what is the meaning of h of 20? The cost of hitting the building when the outside temperature is 20. What is the meaning of h of 30? The cost of hitting a building if the outside temperature is 30 degrees centigrade. When the outside temperature is 30 degrees, it's basically a hot weather, and so the cost of hitting should be 0 or very small number, because already the weather is good and it's enough, there is enough heat. What is the meaning of h of 10? And what do you expect about h of 10? Of course, h of 10 is a bit maybe big number because the outside temperature is 10, and so the heating cost is a bit high. And what about h of negative 5? The outside temperature is negative 5 degrees centigrade, so it's cold, and so the heating cost should be probably high. So we have an understanding now from the function h of t. The first question is this: what is the interpretation, or what is the meaning of h prime, not h prime at 12, h prime of 12? What is the meaning of this? You can pause the video, try to write the answer for yourself for this part of the question, and then continue watching the video. When we see prime, it means derivative. But what is the derivative? What is the meaning of derivative in this question? Remember, derivative has one interpretation that is useful for word problems. Rate of change. We remember when we find derivative has different interpretation. A slope. But definitely here, derivative doesn't show a slope. A slope of what? Here the question is about heat. So h prime shows rate of change of heat, because derivative of a function can show instantaneous rate of change, or rate of change, if you want to say it's simpler, rate of change of the function. So what is finally the interpretation of h prime of 12? We can say the interpretation like this: h prime of 12 shows rate of change. We know that the derivative is rate of change. Rate of change of heating cost with respect to temperature when temperature is 12 degrees centigrade. Remember, derivative has this interpretation: rate of change of the function with respect to its variable. The variable of the function h is t. And what is t? Temperature. That's the reason it's good to mention with respect to temperature. If you simply say rate of change, it's right that this shows rate of change of heating cost. But we can say it this way in a more complete way. In the next part, we are asked what is its units. What is the unit of h prime of t? First, let's see what was the unit of h of t. The unit of h of t is $. Derivative, or rate of change, the unit for h prime of 12 or h prime of t would be, the unit is $per degree centigrade. Why the unit is this? Let me explain it to you. You don't need to memorize anything. The definition of average rate of change or instantaneous rate of change involves a fraction. In the numerator of fraction, we have change in the function. In the denominator, we have change of the variable. The numerator is the function, and the unit of the function is dollar. So in numerator, we have a dollar. In denominator, we have change in the variable. What was the variable? Temperature. What is the unit of the temperature? Degree centigrade. So in the denominator, we have degree centigrade. That's the reason we say the unit of average rate of change or instantaneous rate of change or derivative, all of these have same unit, is dollar per degree centigrade. Would you expect h prime of 12 to be positive or negative? What do you expect? Again, I recommend you pause the video, try to answer this by yourself, and then continue watching the video. Let me give you a hint. Maybe it helps you. What is the meaning of h of 12? Forget the h prime. Let's see what is the meaning of h. Remember, what is the meaning of h of 12? The heating cost when the degree, outside degree is 12. What is the meaning of h of 13? The heating cost when the temperature is 13. When the temperature increases from 12 to 13, the outside temperature, attention, increases. You expect what happens to the change in cost? Do you expect it increases or decreases? When the outside temperature increases, you expect to pay less for heating a building. And we know that this shows rate of change when the temperature is 12. If the temperature already is 12 and we want to know what happens if a little change in temperature happens, because increase in the temperature causes h to decrease, the cost we pay to decrease, so we expect the h prime of 12 to be negative. So we can write our reasoning in this way. When outside temperature increases, the cost of heating decreases because we need less heating. The cost of heating decreases. So h prime of 12 is negative. Let me explain this in another way. Suppose the horizontal axis here shows the temperature, and here the y-axis shows heating cost. So this is heating and this is temperature or T, not time, temperature. Of course, here shows cold weather, here shows hot weather, the temperature increases in this way. What do you expect to be graph of this function? Again, remember, h of t shows the cost. When the temperature, the outside temperature is cold, when we have cold weather, the cost is high. But gradually, when temperature increases, the cost of heating the building decreases. So we expect to have a function like this. When the outside is cold, the cost is high. Gradually, when the outside temperature increases, the cost is less and less. and maybe at some point it would be 0 because there is no need to hit the building. H prime is derivative, and you know that one of the interpretations for derivative is a slope. A slope, derivative, instantaneous rate of change, all of these are the same, but different interpretations. If it is a slope, what is the slope of your curve at any single point? Not only 12. At any single point, the slope of your curve is negative. This is another way that you can find h prime of 12 is negative. I hope you liked this video and see you in the next videos.